Well, today we're going to study operations on real numbers. First of all are your lesson objectives. Please make a note of those in your notes for this lesson. There will also be some vocabulary and some tables that you can find. The lavender boxes that are in your book highlight some important content, and you'll probably want to put those in your notes as well. So first of all, let's add real numbers. We're going to add two numbers that have the same sign. So you simply add their absolute values. Use common sign as sign of the sum. So in other words, if both signs are the same, your answer is going to have the same sign as what your two values do. Now what if the two numbers have different signs? Well, you take their difference. So different, you take the difference, and then you use the sign of the larger absolute value. So for example, we have a -3 plus 6 plus a -5. Order of operations, -2. Now let's subtract real numbers. We're going to substitute the opposite of the number being subtracted and then add. So whenever you have a minus sign, it's the same thing as adding a negative number to it. For example, -5 minus 6 minus a -3. So we could say plus a -6, and minus means +3. So negative times a negative is going to make that positive, which we'll be discussing here in a little bit. But our answer here would be -8. -11 plus 3 is a -8. Multiplying or dividing real numbers. Multiplying or dividing two real numbers with the same sign, the result's going to be positive. It doesn't matter if that same sign is both negative numbers. The fact that they're both the same sign and there's two numbers, the result's going to be positive. Now if they've got different signs, your answer is going to result in a negative number. We have 4 times a -2 times a -3. So 4 times -2 is -8, times 3 is -24. One thing to notice, we've got an odd number of negatives, so our answer is negative. What happens if we have an even number of negatives? That means our answer is going to be positive. So even if you've got 3, 4, 5, doesn't matter how many numbers, if you count your negatives, if there is an odd number, your answer is going to be negative. If there's an even number of negative factors, then your answer will be positive. Reciprocals. Reciprocals are two numbers whose product is 1. So like 2/1 times 1/2 will give you the answer 1. The quotient of any real number in 0 is undefined. So whenever you have a 0 in the denominator, your answer is undefined. However, if 0 is in your numerator, your answer is going to be 0. So the quotient of 0 on any real number is equal to 0. If a and b are real numbers, a over a negative number is the same thing as -a, because your solution is still going to be negative. If there's one negative, then your answer is going to be a negative. A fraction is not in its simplest form if you're leaving a negative in the denominator. It makes the whole fraction negative. For example, 8 minus, and then 3 times a -2 is a -6, and 2 times a -3 is also a -6. We can continue to simplify, making this 8 plus 6. This is a -9 plus 6. So 14 over a -3. So our answer is -14 thirds. This is the format that I would like to see your answer. Exponents that are natural numbers are shorthand notation for repeating factors. So 3 to the 4th power is just 3 times 3 times 3 times 3. We'll take this base of 3 and multiply it by itself 4 times. 4 is the exponent. It's also known as the power. And note by the order of operations that exponents are calculated before the other operations. Remember PEMDAS, parentheses, exponents. Multiply, divide, left to right. Divide, subtract, left to right. Or add, subtract. I said divide, subtract, didn't I? So we're going to evaluate 3 to the 4th power. That's 3 times itself 4 times, which would be 81. 3 times 3 is 9. 9 times 3, 27. 27 times 3 is 81. Now let's evaluate negative 5 squared. Notice this negative is inside the grouping symbol. So that is a negative 5 times negative 5, which is a 25. An even number of negatives results in a positive answer. Notice we do not have a grouping symbol on this one. So it's the opposite of 6 times 6, which will be a negative 36. So be careful when simplifying expressions such as this negative 5 squared and negative 6 that is squared. Without the parentheses, the base to square is 6, not negative 6. So this will be 2 times 4 times 2 times 4 times 2 times 4, which is 8 times 8 times 8, or 512. Another note for you is when grouping symbols occur within grouping symbols, remember to perform operations on the innermost set first. And we have 3 times 4 squared, which is 3 times 4 times 4, which would be 48. Now we're going to evaluate these expressions. We're going to find 3x squared when x is equal to 5. So again, I keep my parentheses holding my place for my variable and insert the 5 instead. That will keep you from making as many mistakes, especially when we start working with negative numbers here. So that's 3 times 5 times 5, 3 times 25, or 75. This is where it's critical because we're evaluating when x is equal to negative 1. So by keeping your parentheses, you see that negative 1 is inside the grouping symbol. So negative 2 times negative 1 times negative 1. Negative times negative is positive. Now if you're just looking at your final answer, notice you've got an odd number of negatives, so you know your answer is going to be negative. We may use exponential notation to write products in a more compact form. So when we've got 2 times 2 times 2 times 2 times 2, well, let's write it as 2 to the 5th power, because there's 1, 2, 3, 4, 5 2's. For these expressions, we can read it as 3 to the 2nd power, or 3 squared, 3 to the 3rd power, or 3 cubed, and then 3 to the 4th power. So evaluate 2 to the 6th power. That's 2 times 2 times 2 times 2 times 2 times 2, which would give us 64. Now, the opposite of squaring a number is taking the square root of a number. A number b is the square root of a number a if b squared is equal to a. In order to find a square root of a, you need a number that, when squared, it equals a. Okay. The principal square root is the positive. If you remember, a negative 5 times a negative 5 will give you a 25, as well as a 5 times 5 will give you a 25. So there are actually two square roots, a positive and a negative, but when we're talking about the principal square root, we're only talking about the positive one. The negative square root is notated, and notice the negative is on the outside, not on underneath the radical sign. That would give you an imaginary number. So the square root of 49, what number times itself will give you 49? Why, 7, of course. On this one, we take the square root of 25, which is 5, over the square root of 16, which is 4. This one's going to be the opposite of the square root of 2, or square root of 4. So it's going to be the opposite of 2. Just some quick notes to add to your notes section for lesson 1-3. order of operations. So if you'd like to pause the video and go back and make these notations, this will help you remember the order to do order of operations. So for example, using order of operations, we know that we need to do our exponents first, so 3 squared. Then we've got division, so 9 divided by 3 is 3. 6 plus 3 is 9 over 9. So we add 3 to 6. So 9 over 9 is 1. To evaluate an algebraic expression, substitute the numerical value for each variable into the expression and simplify the result. This may look familiar to you. We've already worked this in a previous lesson. All we do is substitute, remember the proper terminology instead of plug it in. Substitute in an 8 for x. So 5 times 8 is 40 minus 2 is 38. And on this one we're going to substitute in a -4. Parentheses are critical, especially when you're talking about a negative. Substitute a -4 in for a. -4 times -4 is 16. 2 times -4 is 8. When we add left to right, we've got a 44. Very good. You're ready to begin working on the assignment.